This is Mr. Beck Does Your Homework, AP Physics, Homework 5.3, questions 9 and 10. Question 9 says, a satellite has a mass of 64 kilograms and is located at 3.77 times 10 to the 6th meters above Earth's surface. What is the potential energy of the satellite Earth system? Well, I know that the gravitational potential energy of two objects is going to be the universal gravitational constant times the first mass times the second mass divided by the radius, the distance between their centers. Now this isn't a squared, this is just the distance between their centers. So this is the difference between energy and force. So my potential energy is going to be 6.67259 times 10 to the minus 11 times the first mass, which is the mass of the satellite, we'll say, doesn't matter which one, that's 64 kilograms. The mass of the Earth is 5.98 times 10 to the 24th, divided by, well, what's R going to be? R is going to be the radius of the Earth plus the height above the Earth's surface. So again, I've got myself a satellite in orbit around a planet, so I've got to have the radius of the Earth plus the height of the orbit. So I've got to have both of those being the R for the satellite. So that's going to be the radius of the Earth, which is 6.37 times 10 to the 6th. And add to that the radius of the height above that surface is 3.77 times 10 to the 6th. So make sure you've got that whole thing in the denominator. And that will give you the potential energy of the satellite Earth system. That's how much energy is between the satellite and the Earth. Now it says, what is the magnitude of the gravitational force exerted by Earth on the satellite? Well, my force of gravity is going to be G m1 m2 over r squared. So I could take this u that I just figured out and divide again by this whole r. So this is going to be the u divided by the r again, because all of this, without that, r squared with only the single r is the u, and then I've also got r. So take the u and divide it by this denominator again, and that will give you the force of gravity between them. Or you can do g m1 m2 divided by this squared, which is effectively the same thing.